So we're starting off with oscillations, or you could say simple harmonic motion today. Whenever we think of this term oscillation, obviously we can recall the motion of a pendulum, because this is one of the examples that you study a lot during the course of your O levels or IGCSEs, because that is one very convenient example that we can consider while understanding the motion, back and forth motion of an object. Because oscillation is also known as back and forth repeated motion of an object around an equilibrium position. So this concept of equilibrium position is very important here. Equilibrium position is the position of rest, or the point where all the forces cancel each other out. If you, let's say, want to understand a more technical definition, it's where the forces cancel each other out, the net effect is zero, or you could say the zero position. And then if an object rotates on the left and the right side of the equilibrium position, back and forth repeatedly, this is known as oscillations. So back and forth repeated motion on either side of the equilibrium position. For example, if let's say you have a pendulum here, this is the equilibrium position, and the pendulum rotates on both the sides of the equilibrium position. This is the rightmost extreme, this is the leftmost extreme. Or you could say x naught is the maximum distance, maximum displacement on both of these sides. This is what an oscillation is. So there are further two types of oscillations. Number one, any idea?
Oscillations का मुझे नहीं पता.
A free oscillation. Second one is a forced oscillation. I think we're just looking at these terminologies, you can guess what these types of oscillations are, right? A free oscillation would be anything without a force, maybe freely moving, and a forced oscillation would be an oscillation forced by applying a force, maybe, and not vibrating at its natural frequency. So there's this term known as natural frequency. Natural frequency is the independent natural frequency at which any object freely moves without the interference of any force. So free oscillation is the one in which an object vibrates freely at its natural frequency just because of an initial disturbance. Initial disturbance could be anything. Maybe you displace the pendulum. Maybe you slightly push the pendulum to one side. You apply wind pressure to anything, and it starts vibrating. It starts moving. This is an initial disturbance. So free oscillations, object vibrates freely at its natural frequency. After an initial disturbance. So, important things: natural frequency, initial disturbance, vibrating freely. All right, these are the key words that you need to consider while writing a definition for free oscillations. A forced oscillation, on the other hand, is when an object does not vibrate at its natural frequency and is caused to vibrate at a frequency higher than that. Right, and that cause could be anything: an applied force, maybe an initial push. All right, obviously higher than the inertial disturbance. So forced oscillation is when an object does not vibrate at its
Can you give an example for each of the
sure,
oscillations?
and is cause to vibrate a frequency higher than that. So an example of free oscillation could be a pendulum at its equilibrium position, and it maybe starts vibrating because of the air around it. Yeah, तो वो अपनी wind की वजह से हल्का सा displace हो जाता है, इधर जाता है, and the vibration starts. This is a free oscillation. Forced oscillation is if you push the pendulum, you drag the pendulum to the rightmost extreme and then you leave it from there. You maybe drop the pendulum from the rightmost extreme and then it starts to vibrate. This is a forced oscillation. All right. Spring and mass maybe. If let's say this is a spring, आपने जरा से spring को हिला दिया, maybe you just slightly move it, so it'll vibrate vertically at its natural frequency, very slight vibrations. But if let's say you attach a mass with a spring, a ball of mass maybe 2 kgs, and then you remove this ball instantly, the spring would vibrate back and forth repeatedly at a higher pace than the original movement. So this is known as a forced oscillation. All right, Hassan, clear now?
Yes, clear.
Okay. You can represent the motion of oscillating objects on a displacement time graph. So displacement time graph looks something like this: time on the x-axis. Sorry, hold on. Okay, displacement on the y-axis, and yeah. So अब इसके अंदर you see this is the amplitude. Not x naught is the maximum displacement, and time period of this one graph, one complete motion till here, till this point. So if you let's say want to calculate frequency, frequency is 1 over time. So you get the time period, whatever the numbers will be on the x-axis, you divide with 1, you get the frequency. Right? This capital T is always the time period. Time period क्या होता है? Time period by one complete vibration, one complete cycle. So this displacement time graph is another way of representing the motion of any vibrating object, any oscillating object. Could be a pendulum, could be a spring, could be a loudspeaker cone as well. You see, when the loudspeakers, when you hear music through the loudspeakers, you can always see slight vibrations in the loudspeaker cones. So this is also an example of oscillations. All right, we're moving on to the concept of simple harmonic motion. Simple harmonic motion, or SHM, is defined in terms of acceleration and displacement. So we will now be looking at the oscillations in depth. Abhi tak we've just studied the basics of what oscillations are, how you represent oscillations, and the differences between a free and a forced oscillation. Now we'll be considering the acceleration and displacement and the changes in these two values in detail. Okay? So need to be considerate of number one, acceleration, number two, displacement. Displacement is obviously the distance covered by the oscillating object in a particular direction, and acceleration is the rate of change of velocity of that object. So examples of simple harmonic motion could be molecules of air, electrons in AC current, and atoms in a molecule. All of these particles, these things vibrate, and they follow a simple harmonic motion. What is simple harmonic motion? It is an oscillatory motion in which acceleration is directly proportional to displacement. I'm writing down the exact definition as well, so you can note it down. It is an oscillatory motion in which acceleration is directly proportional to the displacement from a fixed position. You can also call it mean position. For example, if let's say, okay, let's understand the keywords here. सबसे पहले तो oscillatory motion, acceleration directly proportional to displacement and the mean position. So let's say this is the mean position, and the object gradually reaches this point, point A, the rightmost extreme. This is where it covers the maximum displacement, right? So the acceleration will be directly proportional to this displacement. We know the object will be accelerating as it moves towards the right side, yeah? And similarly, when it moves towards the left side, reaching another maximum displacement, it will also be accelerating, but in a different direction. So both acceleration, okay, remember, in a simple harmonic motion, the acceleration and displacement are in opposite directions. Why? Because even if you look at this case of pendulum, although it's moving towards the right hand side, the acceleration will always be acting towards the mean position, the zero position. Any idea why? No? Hassan, are you there?
Can you repeat the question? My definition note.
Which I was saying कि here when the object accelerates, when the object moves towards the maximum displacement on the right side, why is the acceleration acting in the opposite direction? I think the signals are breaking because Hassan, can you hear me now?
Yes, I can hear you, sir. टाइप कर
आपकी
नहीं
आवाज
आधी
मुझे हाँ
क्योंकि आप आधा क्वेश्चन बोलते हैं तो वो आधी समझ आती है फिर बाकी आवाज नहीं आती आधी
अच्छा अब आवाज सही है आ रही है
जी जी आप सही है
okay I was asking कि acceleration why is it opposite to displacement why is it in the opposite direction to displacement so let me know if the voice breaks again. All right. So the question I was asking was कि I'm saying कि simple harmonic motion में when an object moves towards one side, it gets displaced maybe towards right in this case. Why is the acceleration acting in the opposite direction?
नो आइडिया
No idea. Acha. So the reason for this is the acceleration is directly proportional to force, and force in this case is weight, which is the pull of gravity, and it's always towards the earth. So the acceleration will always be acting in the direction of the force. Okay. So assuming
ठीक
that
है
this object is displaced towards the right hand side, towards this position X, So obviously the gravity is acting downwards. So when it's, let's say when it moves back, so the acceleration will be acting in the same direction. Even if it, let's say, travels upwards. In any case, the acceleration would just be acting towards the mean position. So the acceleration and displacement are in opposite directions. This is a characteristic of simple harmonic motion. A is negative omega square x. This is the formula for it. This formula represents in simple harmonic motion. For instance, A is acceleration here. Omega is a constant and x is displacement. So number one, you see acceleration is directly proportional to displacement. Omega अगर constant है, A is equal to A is directly proportional to x, and this negative sign indicates the opposite directions. All right,
क्या x किस चीज की वैल्यू मिला?
x is the displacement.
ठीक है.
ठीक है, तो नेगेटिव साइन ने आपको बता दिया कि both of these quantities are in the opposite directions, and this constant explains that they're directly proportional. So I'm once again going to draw this pendulum here to explain. सबसे पहले तो this rightmost is the extreme position of this pendulum, or you could say the maximum displacement, and this is the mean position here. So following A is equal to negative omega x, this explains that when the pendulum travels towards the right hand side, the acceleration is acting towards the left hand side. Direction of A will be towards the mean position. This is a fact. So the direction of acceleration is towards the mean position. And the displacement is towards the maximum position. So displacement is towards the max. And why? Because we already know the object is obviously moving towards the right hand side. So displacement towards right, acceleration towards left. This is an explanation of this simple harmonic motion. Let's look at the same scenario in a little more detail. Once again, I'm going to draw the same pendulum. So ये तो हमने establish कर लिया कि this is position A and this is position B. So position A is the mean position. So hold on. All right. At mean position, you already know that the displacement is supposed to be 0 because the object, this is the mean position. I mean, this is where the object was initially. The displacement will have to be 0. The acceleration is also 0. The velocity is maximum at this point. He is the mean position. The object will be traveling the fastest at this point. If the velocity is maximum, so kinetic energy would also be maximum at this point.
Velocity will be 0 at the extreme position, right?
Exactly. Elastic potential energy, is 0 at this point, and the total energy remains constant. Why constant? Because if kinetic is maximum, the gravitational potential will be 0. And if you look at the extreme position, at this extreme position, the velocity is supposed to be 0 because the object would momentarily be at rest. X naught, the displacement is maximum. The kinetic energy is 0 because the velocity is 0. Elastic potential energy is maximum because it's maximum so the elasticity is maximum at this point, and the total energy.
What about the gravitational potential energy?
Gravitational potential increases with distance, right? So if kinetic is 0, gravitational potential would be maximum at this point. And gravitational potential would be 0 at the mean position. ठीक है?
ठीक है.
So ये you need to know all of these changes. I'm giving you a minute to note all of this down.
Just give me a minute.
So,
Yes, continue.
all right. So let's understand the same concept through a graph as well. If let's say we try to draw a graph of velocity against displacement. So this is v meter per seconds, and displacement. This is where the displacement is supposed to maximum. So and the pendulum की जो positions हैं, let's say कि it starts from the extreme position. Extreme position पे हमने क्या कहा था? The velocity is 0. Sorry, mean position. Velocity is 0 at mean, right? So 0 velocity is on all of these, um, or the entire x-axis. If the velocity, अच्छा हम उसकी बात कर रहे हैं, mean की velocity maximum on the entire y-axis. इस पूरे y-axis पे जो displacement of 0 होगी, ठीक है? So this is the point. All right, let's consider this as the maximum velocity point. Mean position. Okay, now the pendulum starts to move towards the right side. Action number 1. Right side का मतलब क्या है? The displacement gets maximum and the velocity slightly reduces to 0. Okay, so this is how the graph would go. This is the first action. Then it gets back to the mean position again. उससे क्या होगा? Velocity would again be maximum, but in negative direction. So like this.
बिल्कुल opposite होगा उसका
Yeah.
circle की तरह.
Up when it moves towards the left hand side, third action, the displacement again gets 0, but in another direction. And the fourth one back to the mean position, like this. Sorry, yeah, it should be in the diagram. All right. Third action, fourth action. This is how a graph would look like for velocity against displacement. Any questions so far?
No.
All right. So the last bit of today's lecture, looking at another graph. So there are a lot of graphs in this topic.
I think अभी तक हम लोगों ने एक ही फॉर्मूला किया है, राइट? वो a is
फॉर्मूला
equal to
एक ही चल
minus
रहा है, हाँ उसी के ऊपर सब कुछ हम कर रहे हैं फिलहाल तो. x naught maximum, negative x naught. अब this is an acceleration against displacement graph. Acceleration against displacement. So acceleration, this is, let's say, the mean position. At mean position, the displacement is 0 and the acceleration is also 0. Now, once the pendulum starts to move towards the towards the extreme position, the displacement becomes maximum, the acceleration also becomes maximum, but in the opposite direction. एक तो ये हो गया, right? Maximum displacement achieved कर ली, maximum acceleration achieved कर ली. And then as you move back on the same lines, you get to zero, and then on the other side, right? Again, maximum displacement and maximum acceleration. So this is the point where max x naught and max acceleration. So how is this graph representing simple harmonic motion? Question ये आता है कि by looking at this graph, how can you explain the simple harmonic motion? Number one, it has a negative gradient. Negative gradient
इसका
explains
ग्रेडियंट ओमेगा देगा ना, मैं ओमेगा
ओमेगा मिल जाएगा,
का
बिल्कुल.
स्क्वायर, आई थिंक उस फॉर्मूला का
नेगेटिव ओमेगा है, तो इसका मतलब क्या है कि आपको वो फॉर्मूला आपका जस्टिफाई हो गया. Yeah, A is negative omega square x. Another thing, line is passing through origin. And the third point is that maximum values for acceleration in omega are same. Displacement same. Why? Because directly proportional. A is directly proportional to x. इससे क्या पता लगता है कि the maximum value of acceleration will be the same as the maximum value of displacement. All right. Okay. Hasn't any questions?
नो, मैं बस ये 1 मिनट ये नोट डाउन कर लूँ, ये 3 पॉइंट्स. यस, हो गया. इज दैट इट?
Yes, I think that should be it because I don't want to start the next part of the lecture right now. It'll get a lot of information for you. Yeah. End the lecture.